Hello students, this is another tutorial on density. We're going to take it a step further and we're going to learn a new skill here that you will be using in a lab that is up and coming pretty soon actually. At this point, everybody should understand how to go ahead and calculate the volume of a simple object known as a cube. And if you don't remember how to do that, you should definitely go back and watch the first tutorial. You already should know how to calculate a cube's density once you know the mass and the volume of a cube. And you also should have sort of at least begun to develop an understanding that different tools allow you to write more digits, more figures in your measurements. And that all depends on how much that tool is calibrated. And I'm going to probably show you some examples of this in the near future so you can get an even better understanding of this. I want you to remember that cubes are not the only thing for which determining volume is easy. There are other objects that are pretty straightforward, maybe a little more complicated than cubes, but not much more. For example, spheres. If you can determine the radius of a sphere, calculating its volume is pretty easy. Now remember, a sphere is a three-dimensional object. This is not a circle. This is like a ball. Cones are pretty easy to figure out volume. And boxes aren't too challenging either. And in fact, boxes are as simple as cubes. But what about irregularly shaped objects? We have a lot of things where sometimes we're trying to figure out the volume of them, and these present a challenge. Okay. We cannot know the density of something until we know its volume. Getting the mass of these things is always easy. As long as they are not too heavy, they work on our scales that we have in the classroom. So we could go ahead and we could put these 3 stones on scales and determine their masses. But to get their volume, yeah, we could use a form of math, but it's highly complicated and not appropriate for 9th grade high school. So we look to a different method where we can do it experimentally. It's pretty cool. And it's pretty easy. Now, I asked the question, how might we do this? Because I feel like some of you might have done this in middle school. And even if you didn't, you might be able to figure it out. So here is where I want you to pause the video, and you are allowed to work with some of the people in your lab team and brainstorm. And I'll give one hint. You would be using the graduated cylinder, and that's the only hint I'm going to provide for now. So let's see if you can figure out a method for how to determine the volume of an object using just a graduated cylinder. Meanwhile, I'm going to go on, but you should be pausing the video right now. Okay, so we use a method that involves water displacement. So you'll notice here on the bottom, the graduated cylinder has 50 milliliters of water in it already. We have to take note of that. We have to know what the initial volume was. Okay, now we're going to take the stone and we are going to drop it in that water. And you'll notice when I did that, let's go back a moment. Take a look at the water level. Okay, see how it went up? It went from, it looks like it's around 60 milliliters now, maybe a little lower. Okay, the initial volume was 50 milliliters. After putting the stone in, the water rose up, and so we have a final volume now. And we're gonna imagine that water rose up somewhere above 59, so we called it 59.5 milliliters. Well, the math here is very easy, right? 59.5 minus 50 tells us that the volume of displaced water was 9.5 milliliters. Okay? Now, I want you to remember that, we went over this last week. Every milliliter of water is also equivalent to a gram of water, and it's also equivalent to a cubic centimeter of water. What does this mean? Well, let's just realize that if the stone displaced 9.5 milliliters of water, that means it also displaced 9.5 centimeters of water. And this tells us, You can't see that down there. There's a question that says, so what does this mean? It tells us simply that that's what the stone's volume is. The stone displaces, the amount of water that a stone displaces is equivalent to the volume of that object itself, or that stone itself. Okay? And so now that we know that stone's volume, the rest is cake, right? We just take its mass that we got from the scale and we divide it by the amount of water it displaced, because that tells us what its volume is. And then we get an answer of 10.3 grams per cubic centimeter. Nice and easy. Now we got to go ahead and do the other two stones as well. So I'm calling it stone number 2. We're going to drop it in. We're going to imagine that it made the water rise up an additional 6.5 milliliters. So what is the volume of this rock? And once you know the volume of the rock, what is its density? Okay. Now you can do this with teammates as well. I'm going to allow that for this tutorial. That's if you choose to. Okay. It is okay to work with somebody else on this tutorial, and the questions that I'm giving you with it, you just have to make sure that you put their names in the document as well. And now let's not forget about the third rock. We're going to take it, we're going to put it in the water, and we're going to imagine that it makes the water rise 8 milliliters. And if that's the case, what is that rock's density? Okay. Again, you're going to need to go back. If you don't remember the mass of that third rock, just go back and find it earlier in this video. Okay, so did you learn? So in today's class, we explored how we could go about figuring out the density for objects that are not nice uniform shapes for us, like cubes. And we did that using a method called the water displacement method. We're going to be doing a lab real soon, maybe as soon as tomorrow. And I'm going to be challenging you to use these skills. And I'm hoping that you can do it without my help. In fact, if you get stuck in the lab, I'm probably going to ask you to go back and watch this tutorial instead of having me, come to your rescue, because I really want you to learn to think it through on your own and persevere through stumbling blocks that you might encounter. Okay. In the meantime, it would be beneficial to review these mini lessons to help make yourself become more self-sufficient during the lab tomorrow. All right. Thank you and good luck.